Yeah,
we're good?
Yes.
All right, good afternoon, everyone, and welcome. We are here to talk about the art of the command line. We are the Linux Users Group. My name is Mike Woldridge. I am the president. This is Matthew Wynn. He is the vice president and our social media expert. Here at the streaming computer, we have Dino. He is our treasurer, measuring the vast finances of the lug. Down here on the end, we have Tim, our secretary. We are the officers of the lug. We do most of this as 4 people here, but we really like any suggestions that members can bring forward. Anything you guys want to hear about, come talk to us. We will do our best to put together a meeting on it so that we can all learn about cool technology. So just to start off real quick, some housekeeping. How did you guys hear about this meeting? Can I have a show of hands for the Facebook group? Okay, 1 person on Facebook. Can I have a show of hands for OrgSync? All right, so we have no freshmen. Can I have a show of hands for the posters? All right, as usual, the posters went out. And anybody here on IRC that heard about it there? 1 at the back, all right.
So posters. All right, we'll keep doing that.
Yes, for those of you that may not be familiar, this is IRC. We do a lot of communications via IRC. It's pretty fantastic. We have all the officers on here, a lot of alumni on here. They talk about cool stuff. I can tell I've got an alumni who's trying to get somebody in here to be their eyes and ears. Yeah, that is what we have. So today, we are here to talk about the art of the command line. Does anyone want to take a guess at why we would say the art of the command line? Why wouldn't we just call it the command line? Or does anyone here want to start out with an even more dangerous guess of what is the definition of the command line? I see that syllabus day took all of the enthusiasm out of everyone.
Wait, what syllabus day? This isn't a class.
No matter.
You swapped.
Yes, I did.
So
I want Launch Shift J to change that and minimize that. So when we talk about the command line, we're talking about the shell. You can see here's my shell. And we're talking about this feature which exists on virtually every operating system that isn't Windows. Windows has the PowerShell, if you've heard of that, or it has cmd.exe. And these are shells of a type. They're not really command line shells. They are command parsers that work in Microsoft's proprietary ecosystem. This is a command line, and this is a shell for the purposes of today's talk. I am currently using the Bash shell, Born Again shell. For those of you that were here at our Jeopardy event, this is a default shell. Most systems come with this. If you log into CS1, one of the university Linux servers, you'll generally be dumped into Bash. And when we look at this, we can see there are 3 key components that you'll see across every shell. I'm going to do the cheater approach and just hit enter to get that prompt down to my height. There is the username. For this system, I am logged in as M. Aldridge. There is the host name, which is Earth. And then this squiggle here is the folder that I'm currently in. I am currently in my home folder, which is signified by the squiggle. And then we have the @ symbol here, which states that I am a user at a host. Now this is very useful because as we proceed through our talk today, we will not always be on Earth. I will switch over and I will be on CS1 here in a bit, and I will be someone else at CS1. And the @ symbol is what always splits the username from the host name. Now this is Bash, but this isn't really where we start with the shell. We're going to jump to, I'll get to your question in 1 moment. We're going to jump to a brief history lesson first, which is that way back when, the shell looked quite a bit more plain. You can see, we have a dollar sign. That's it. That is the entirety of this shell. And it's quite a bit different. If we get the version for this shell, we can see that this is the AT&T Research Division's shell. This is KSH. And this is the shell that was available in the very first version of AT&T Unix. This was the first version which was actually split out from SH. And it's very simple, very plain, very old. However, KSH is fully compliant with the standards which specify a shell. By this we mean that if you type certain characters in, there is a defined way in which they will be handled. A good example is quotes, double quotes versus single quotes. There is a defined way in which those are handled, and KSH satisfies this standard. But KSH is old. KSH is generally very unhappy. If we type things like help, help, not found. Well, we're not getting very far there. So we're going to jump back to something more friendly. Here, if I type help, I get help. So there is your brief history lesson. We started out with KSH. And it's not particularly friendly, but still has all of the full power. We can launch any program we want from the shell. It's just not helpful. So here is Bash, and here is where we will start. Some of the reasons you would want to use the shell, as opposed to using a graphical environment with a mouse, since this is something unique to non-Windows systems, is that the shell is faster. If you think about it, just from a basic standpoint of if your hands are on the keyboard and you have to do something with the mouse, it's going to take you time to get your hand off of the keyboard, onto the mouse, do whatever you're going to do, and then find that home row again. By doing the majority of the work in the shell, we negate this time penalty from taking hands off the keyboard and back on. The shell allows us this additional speed, if you will, that we don't have to go hunting for the mouse, which has run itself away from its mouse pad or whatnot. A good example of things that we can do in the shell that we can do anywhere else, we can edit files, we can manage our directory hierarchy, we can compile code, we can do just about anything you might want to do in any other system. The only thing that comes to mind, in fact, that you cannot easily do in the shell is watch a video or look at a picture. And that's primarily because the shell is a character-driven device, and it's kind of hard to get video using characters. Now, it can be done. The most famous example is if you telnet to a certain address, you'll be greeted with a text-based version of the movie Star Wars. So it can be done, but it's not necessarily going to be possible to watch Hulu in the text-based shell.
It's in color if you're in IPv6.
Yes, you can watch Star Wars in color if you're in IPv6. Yeah. So before we proceed, does anyone have any questions about the basic idea of the shell, what it is, why we care about any of this? So your head first.
So is the shell faster because the language is closer to the machine language, or is it just because of the execution time you use them?
Okay, so the question was, why is the shell faster? Is it because it's closer to the machine? The short answer is, it depends. For certain things, the shell does allow you to be closer to the machine. It's a lot easier to express the idea of copy this file over to this location with text than it is with a mouse. But for the large part, the shell is faster simply because you're already there. On my computer, I can launch a new shell with one chord, where I would hold two keys down. As opposed to in Windows, if I need to go get a PowerShell instance, I'm going to go down to my Start menu, and then I'm going to go to All Programs, and then Accessories, and then System Tools, and then I think PowerShell is in that menu. It may be one deeper.
To be fair, you can search for it.
Well, yes, okay. If your Windows system is configured properly, you can search for PowerShell.
I have an even more basic question. Just being a complete novice, what is a shell?
A shell is what you're looking at right here. It is this black field with text on it, and we can type things into it and it will do things for us.
It's just an interface.
Yes, it is literally an interface. In the back?
So we have different shells, yeah? How can we install different shells on our OS, and how can we access those?
Okay, so the question was, how do you get these different shells, and then how do you access them once you have them? In the case that I'm going to be working with up here, my laptop runs Linux locally, so I would install these shells with my package manager, and then I would launch the shell just like I would launch any other program, which is I would type its name into a run interface.
Is Bash a shell?
Yes, Bash is a shell.
Okay.
So, and the shell specifically is a program which runs in some kind of an interface that can present it to a human. In this case, I have a terminal open, and the terminal is my interface, which is running the shell. But you might just the same run a shell on a remote server, wherein the thing that presents it to you is whatever tool you use to log in remotely. Okay. Any other questions before we proceed? All right. So I've given a brief overview of Bash and one other. Before we get too much further into what you can do with the shell, there are one or two other shells we want to show. One shell that we will be showing, and I'll go ahead and show it next, is one that you cannot use on the CS cluster because it is not installed. I have an email kind of in the works to see if I can get it installed, but we'll see how far that goes. And it is Fish. Fish is the friendly interactive shell. If you have access to a Linux computer where you can install arbitrary software, or a Mac, because a Mac for our purposes is going to be a Linux computer, you can install Fish. It is much friendlier than any other shell. Now, Fish also has perhaps the greatest tagline of any program available, which is, "Finally, the command shell of the 90s you've always wanted." It's just a little bit funny, though, how Fish wasn't released until 2005. But they assure you, it's the shell of the 90s you've always wanted. And part of what makes Fish so nice is it has so much that is auto-completed for you. I don't actually have to type everything all the way out. I can just start typing and Fish will give me suggestions. And it will also auto-suggest out of my history. So recently I was needing to troubleshoot why I couldn't get to the LUG's website. So I have MTR, my traceroute. If you've taken the networks course, you've seen this. And you can see it auto-completed that command out of my history. I typed a little bit and then just very quickly accepted the suggestion. It also has this very nice highlighting, which it does, that I can quickly and easily separate out the difference between a command and the arguments to that command. So Fish is very nice. I'm actually in the process of switching over to it. I liked it so much over Bash. But my associates over here use a different shell, so I'm going to call Matthew up now with his laptop. And he's going to show you guys the Z shell. Yes, with power language. One moment to disconnect, and you will need to have the bar.
Very cool. Okay, so here I am using Z shell.
You need to move your split over.
Yes. Now Z shell is very similar to Bash. As you can see, I have my username, my host name, and the squiggle to show that I'm in my home folder. But ZSH is for power users. It is very customizable. If you were to install ZSH and run it on your system, you would not get a prompt. You would get something asking you to set it up, to start customizing how much and what kind of tab completion you're going to get. Just to show you, this is something that Fish can't do. I can say I want to grab a window. If I hit tab, it knows what that command is. It knows what kind of program or what kind of tab completion needs to happen for that command. And it's giving me the options for what would go next in that command. And I could keep going from there. Another thing ZSH gives you is there's so many plugins. My colleagues here like to talk about. Yes.
That ZSH is available on CS1.
Oh, ZSH is available on CS1.
Yeah.
Very cool. Oh boy. Oh, look at that. And see, it asks me, how do I want to configure? And I'm just going to say quit and do nothing, and I'm given a very basic shell. But if I were to continue on customizing the shell, installing plugins for ZSH, setting up my ZSH RC, which is just a config file, I can get all kinds of stuff. You notice here I have some Git information, a timer there. It's a very powerful shell, all kinds of completions, more completions that you could ever ask for. Not quite as friendly as Fish, but I would say more powerful and more customizable if that's your thing. What do you want to talk about next?
Let's show some basics of navigating the file system in the shell.
Sure. Okay. So some people like to use the shell as their file, almost like their file manager.
Louder.
All right. So no file manager. Instead, we're just going to use the shell. So here I'm going to see what is in. I'm going to cd to my root directory, and I can type ls, and I can see all of the folders and files there. There aren't actually any files in /. I can go into then boot ls, and I'm navigating the directory here. As is the case with ls, we have some options that we can find with ls help, or ls and tab will help us. We can get information about all the files here. And so some people find it very helpful to use the shell to navigate through their files instead of pulling up a file manager where you have to double click to navigate through folders. Here, if I wanted to just go to an arbitrary location, I can go there with plenty of tab completions for me, and it's very great.
How would I learn about these commands?
You can learn about any command by using its man page. Its man page is its manual page. So say I see, oh, I've used ls. I want to know more about ls. I can type man ls, and it will give me options. It'll say, here's the name, here's what it does in its basic syntax. Say, here are all the options that you can do with ls. And ls is a pretty powerful tool. We have a lot of options here. And then full documentation, where to learn more, author, and all that. And then I can finally hit Q to quit man.
Does it work if I type man?
It does. There is a manual page for man itself. And I will tell you how to find, or how to use man, what each part of man means in extreme verbosity. I'm hitting page now and we're still going. Sure. So we've covered all of, how to navigate the file system basically. One other thing that I want to show is PWD. PWD stands for Print Working Directory. I'll just say, yes, this is where you are. It doesn't ever get lost. And of course, I can just type cd to get to my home folder, or cd/ to get back to root. Some other basic commands that we want to talk about are cat. let's go back there. Okay, we have files here. I'm going to cat screen. I don't know what this actually looks like. And it's going to print that file to the screen so I can look at it. You want to talk about grep already?
Good.
All right. Another thing that we can do is grep. What should I grep? What's a good thing to grep?
If you jump up one layer, there's going to be the main CSS file.
Okay.
Oh, I said there's going to be the main CSS file.
There's not.
Yeah, style CSS.
Okay. So let us look for font. We say we want to know what font are we using for each part of this website here. So I can do a grep command, a regular expression that I can use to search all of these files at once, and a lot more speed than I could through any graphical means. So grep tech I for case insensitive. I'll go ahead and put an R on there for recursive. Even though we don't have folders in here, the R would have it go through any subfolders and anything below that. The string I want is going to be font, and then I'm going to say dot. Dot stands for this current directory. I'll hit enter, and it's going to give me everything with the word font in it. So that's fairly handy. grep has a lot of cool tools. I could use some regular expressions in here. I think I might need to do that. I don't know what flags I need for that. But I could use regular expressions.
An important thing to point out is that there, if you see the glowing green grep, that is a command. There are tens of thousands of those. I believe if you hit triple tab, ZSH should tell us how many. No. Kill grep.
Okay.
Triple tab. And it should all.
No, I don't have that set up.
Well, there are tens of thousands of commands which you can run.
I have 5,726 currently.
I need to install more.
I should.
And as you can imagine, it's difficult to remember all of the options to all of the commands. That's why we have the manual.
Another thing that's very helpful for this is aliasing. And so I can show all my aliases. Since there's no way I can remember all the commands, like what does all of these stand for, I don't remember. But I can remember this short thing, and I don't actually know what that does anyway. But you notice I have aliases, thing equals long thing. So let's say I wanted to set up a new alias to SSH into CS1. How do I do this? I can check man alias, and it will tell me how to define an alias. And so then I can just say, okay, alias CS1 equals SSH cs1.utdallas.edu. And then I can just type CS1, and it will SSH for me. So that's very helpful and useful as you go on. When you have long, complex commands that you don't necessarily want to remember all of, you can alias them to things that you definitely can remember. You want to go through Python filter?
Sure. You want to do that or you want to?
If you want to, you can.
Sure, I'll take it.
All right. Now we're going to talk about what makes the Unix shell so powerful with pipe and filtering.
While we're switching back, any questions about the basics of file system navigation or things like that we can answer for you?
So when you use the alias, can you set it equal to like multiple commands at the same time, or can it just be one?
You can set it equal to as many things as you can string together as long as it remains valid shell syntax. An example is I was working with another person one night on some software and got to the point where they really just needed me to deploy the files onto the server using my login, and I eventually just created a alias, which was do the things. And when I typed do the things, it would run a complete Java build, generate a jar, securely copy it to the remote server, restart a half dozen services on the remote server, and then report back to me the status of if the new build had worked. Now you can imagine that it probably didn't work, given that I had to do this enough times to build an alias for it. So, yes. Very good.
Can you include aliases in an alias?
Yes, you can put an alias in an alias. You have to think very carefully at that point to make sure you don't accidentally create a loop. Because if you create a loop, the command parser will sit there trying to unroll the loop. And it won't. Good question. Sure, I'm going to mute for one moment here.
Question. To add a point, a lot of stuff in shell that you can do is not necessarily something you should do.
Yes. Okay. Had to double check that was a file for an assignment that passed by. So I'm going to be working with this file here, assignment1.txt. It's a convenient file that happens to have a lot of text in it. The thing that makes the Unix shell the most powerful is the architecture on which it is built. The architecture is called the pipe and filter architecture. If you look at your keyboard just above the Enter key, sharing the same button as the backslash is a single vertical line. That vertical line is called the pipe character. And in the shell, we can use that pipe character to create long chains of commands that do something on the input that we provide. So the simplest pipeline that I can think of, we're going to use cat to spit the file out, spit it into a pipeline, then we're going to spit it into a program that will allow us to scroll up and down within the output. So if I hit enter, you can see, here's the file. And for sake of argument, I can actually call less directly on it. And we can see it's the same file. But it means that it went through the pipeline. Cat parsed the file first, spit it out on the standard output, and then it went through the pipeline into the next command in the chain. Now, this does not seem very powerful when we're using it to view files or things like that. This can become much more powerful if we start combining more and more commands with the pipes. Somebody throw out a task of text manipulation that I could do. Cut. What would you like me to do with cut here? Because I'm not thinking the same.
Cat delimited file?
Have a CSV file.
Okay.
Okay, so let's say I'm going to mute one more time here. I need to verify that this file is the one I think it is. Yes, that is the file I think it is. So, I have a file here with some names I pulled from a directory such that I could send an email to some people. If we look real quick, it's you can see it's a comma-separated file. If you've used Excel, then you know it can spit out your spreadsheet as comma-separated values. Now, what if I only want the net IDs out of that file? Because in order to start building together an email list, I don't care about their names, because that's the email system will add those for me later. Let's say I just want the net IDs. Now, those were in the third column in that document, or for our purposes, the second column, since we will state that they are 0 indexed. So I'm going to spit out my spreadsheet file here, fire it through a pipeline into cut, and I'm going to specify I want the second column, or the second field, if you will. The F option stands for field. And I'm going to specify that my delimiter is a comma. So I have this pipeline now. It's going to take in a file, and then it's going to spit out just the net IDs for me. So if I run this, actually, it's not going to spit out just the net IDs for me. Yeah, there we go. Never can remember if cut is 0 or 1 indexed. Yes, I have some net IDs here. Now let's say that I want to start sending from the other end. Like I'm working with a loop, I'm going to take in a net ID, send it in an email, move to the next net ID. But we always start at the start of the alphabet. I don't want to do that. I'm going to start at the other end. I'm going to ask that one of my associates over here get me the option for sort to reverse a list.
Sort. Sort that off.
Is it our? Yes. And so I've now taken my output from cut and passed it into sort, reversed my list. We can even start doing, we can pass this back into less. That's where I'm going to send it. So that now I have these in a buffer. I can inspect it. If I had a longer list, this would be much more useful because then I can scroll up and down in this list.
Can you save that to a file?
Yeah. And I can eventually spit this out to netids.txt. And here I have a text file now that has the results of the text processing in it. So there's an example of how we can start doing pipelines. Let's jump back up here. What if I know that I have a send limit? I can only send so many emails at once, and I want to know that I'm not going to exceed my send limit. Well, then I know that, okay, each line in that output represents one email, because it's one email address, and I want to count them. I can use the word counter, operating in line mode, to tell me that I have 21 addresses there. And what it's doing is it's just taking, via the pipeline, it's taking the input from all of the processing I did previously, and then it's counting up how many lines I have. If I wanted to do useless statistical analysis, I could count how many characters are there. There's 210 characters in 21 net IDs. We would certainly hope that there are 210 characters since a net ID is a standard length. Maybe we want to know how many bytes are in there. Right now, bytes is going to be characters in this case because I am not on UTF-8. We could ask how many words are in there, and in that case, this would be the same as the number of lines because I have one word per line. It'll be 21 words. So that is some basics of pipeline processing. Now here we are passing only human-readable text through the pipeline. It is possible to do things on more advanced systems. You can pass actual binary data through the pipeline. You can. There is a suite of software called ImageMagick, which used to be how we would edit images before the days of Photoshop or the GIMP. It has the ability to spit the image data out on the standard output. And of course, to us, this looks like just binary garbage because it's exactly binary data. But to the computer, it can take this into another program, read it right back in, and it's just like it had it as a file. ImageMagick is actually, ironically, not available for my operating system, despite the fact that ImageMagick is a cockroach that will never die. And is available for a myriad of systems. It is not available for this one. Good example of binary data. Another one, if you've ever heard of the ZFS file system, the single most over-specified file system out there, it stands for zettabyte file system. That is a 1 followed by, I believe it is 1,000 zeros. Though it has been a while since I have looked that up. The ZFS file system has the ability, let's say if I want to send an entire image of my disk from one server to another, I can do ZFS send. And that will take the status of whatever I ask it to send, it will serialize it into a stream, and then it will spit it out on standard out. Generally with ZFS you would then want to send that securely since it's someone's data, so you would spit it into SSH. And SSH, our secure shell program, will allow us to, in a cryptographically secure manner, send the data across the network to our receiving server, where we can run ZFS receive. And because we've sent the data through this pipeline, goes in on one end, comes out on the other, and arrives in one piece. The programs on each end understand how to handle that. Have I lost anyone here? Or am I still...
How would you use that less netid.txt? How did you copy it using less? Can you explain?
Use it, can you clarify your question a bit? I'm not quite sure I understand what
so
you're
you
saying.
use pipeline to do certain things, and
Mhm.
then there is less command to copy the portion of it into another text file. How did you do that?
Okay, so less is not actually copying the file. Less is only ever able to consume a file or a file resource and show us what it is.
Okay.
When I duplicated that into the netids.txt folder, if you'll see the very top line on the screen here, I have an angle bracket. And the angle bracket is acting kind of like a funnel, if you will, saying take everything that's coming out of this pipeline and put it into the file that I'm about to specify. So I specify the file netids.txt and use the angle to spit it in. We can use an angle that faces the other way to read from a file into a pipeline, but that's much more infrequently used. I saw your hand first.
Is there a command for like rotating the words on a line? Like taking the first file and then taking the netids, putting them at the front, and then shifting everything else over so netids can go before.
Okay, so the question was, could you use a command to do manipulation within a CSV file? Things like transposing columns. The answer is yes. There are 2 or 3 ways you can do that I can think of. The first one, and the rather naive one, is you iterate on the lines in the file, and you literally read in the file and then print out a new file with them in the order you want, using just a brief shell script. You could do it with a stream manipulation tool like SED or awk, which are very powerful text processing tools that you can put in the middle of a pipeline. SED and awk, though, are more akin to the statement, if you've ever heard, if you have a hammer, everything looks like a nail. SED and awk are tools like that. Very large, very powerful, and people tend to apply them to small problems that would be better solved using other methods. I believe the easiest solution to your transpose problem is actually a command tr, which is transpose. And I believe it has an option for column rotation within a text document. It's been a while since I've used transpose, though, so I'm not entirely sure.
Are you going to show SED?
I will not be showing SED, just because SED is a rabbit hole that once you start going into it, it becomes very complicated very fast. I would highly encourage you, though, to read the manual page on SED or awk if that's something you're interested in using.
Phi claims that TR would not do that.
Yes, we have our resident shell expert of the club is in IRC at the moment, and he's providing constructive feedback, is what we'll call it, via instant message to us.
He also claimed you can do it in ed.
Yes, you could also edit the stream with ed, but yeah, no one actually does that. So yeah, that is some brief examples of pipelining. Any other questions before I move on?
Actually, I have a question. So, the symbol that you use to put everything in a text file, could you also use that instead of the cat at the beginning to read from?
Yes, I could have used that at the beginning. I would have removed the first pipeline and the cat command, and I would have used the leftward facing angle directly into the cut command. And I could have read the file in that way.
So there's no, so any kind of text format, I guess, I mean, it doesn't have to be .txt in order to use that symbol, right?
Indeed. That will work with any file on the system, including binary files. Yes. It's worth noting that CAT stands for concatenate. The true purpose of that program is to concatenate two files together or two streams together. I have seen it used that way twice in the 10 years I've been using Linux. Yeah, I have never seen anyone actually use cat for what it was intended. It makes a very good way to start a pipeline, though. That's how I tend to use it. Good question. All right, so moving right along. Within our process pipeline, we may wish to do some job control, where we can say, maybe not pass on this information to the next stage of the pipeline, but perhaps only proceed if this command was successful. We can do, there are shell commands which allow us to do that. If we just want to split the pipeline, we don't actually want to continue, then we would use a semicolon. And the semicolon will say, I have completed my current pipeline, proceed with execution at the next available command, do not carry any data over from my current pipeline. Because you can even think of a single command as a pipeline. We can use the semicolon, though, to join pipelines that don't take data from each other. So I have my NetID folder here. Let's say I also want to view the assignment file again. Using the semicolon, I'm able to put multiple commands on one line, and then they will be executed serially. So it will complete running the cat program, and then it will switch over and it will run less. But importantly, no data from the cat program is forwarded on to less. And we can see here, I'm now in less, and when we quit out, it did in fact cat the NetID file. What if I want to run less if and only if the prior command completed successfully? Okay, well, so we're going to cat our NetIDs file, and using a Boolean AND expression, call less on the assignment file. So what this ampersand does is, just as it does in C, it checks the first expression and says, is this true or not? And in this case, if it is true, run this second expression. Now, as in C, if the first expression is false, it doesn't matter what the second expression is, because it's an AND. And in order for the AND to be true, we need both to be true. So we won't even run the second expression if the first is false. And of course, we can see that we successfully were able to cat a file. There are very, very few things that can cause that to fail. So we were then able to call less. If I get a command that does not complete successfully, such as I believe bin false will give me the status I'm looking for, then yeah, we can see bin false did not exit successfully as far as the shell is concerned. So we did not go ahead and run less, because I said I only want to do this if the first command exits successfully. Bin false being a handy command that I know is false. Likewise, we could say, do this or do that. Somewhat less useful in rare circumstances, but I have seen it be useful. So in this case, the first one is false, so we will do the less command. You can see that works just fine. If we do bin true, then bin true completed successfully. We do not proceed, we do not do the less command. We proceed as we were. Sorry. Have we got everyone thus far? Okay.
Can you show how to append to a file?
With the double? Okay. What? Okay. I'm gonna, so for sake of argument, I'm going to copy. So because you guys don't know what these files are, I can make up what the contents are. We're going to say that I was installing onto a ThinkPad here, and that is what this install log is. And this local retry file was also part of that install. Now we're going to say that I'm sending this off for analysis, and I want those to both be in the same file, so that I have the tech on the other end can read both of these files and can say, aha, you're missing the semicolon here, that's why it doesn't work. I can use the, so I'm going to use cat to spit both of them out, and then I will use a double arrow to spit out both of them appended to each other in the tech, in a single file. .txt. But if we look at local, let's see, I have some lines there. I have some lines there. And now they're both in the same file here. Did I go too fast?
Run it again.
Oh, okay. And of course, I can keep appending to that file and just keep winding up with more and more in my appended file. And then if I want to say, okay, I don't care about what's in the log, I want to just take everything out of the current pipeline and save it and only it, the single bracket will overwrite everything in the other file. You can see we're back down to, this is it, there's nothing else in the file. Is that where you want me to go with that? Where? All right. Whoa, come on. All right, so moving things around in the shell, doing things with pipelines is all good and well. But what if we want to actually edit a file? Then, of course, do we have to go spin up some IDE or something? No, of course not. We can do that in the shell too. So I'm going to jump into Okay. So I have here a make file and a .c file for a project I was working on. I'm actually going to go to a short prompt. So yeah, I have my make file, an executable file, and a C file. Now let's say I want to edit this .c file. I'm going to load up my editor here, which is Emacs, on that file. And here we go. We have the entire contents of the file ready to run. Okay. Thank you. Yeah. So yeah, we can we have a complete environment here. We can edit this entire file. I personally do not like IntelliSense. That is the technology, if you've ever used a Visual Studio, that suggests code while you're typing. It is possible to have that in this environment, but I do not like it. If you want to see someone who has a absolutely incredible configuration set where they have IntelliSense and they have everything going on, go talk to Ivor Page. He has had his configuration for this editor for 30 some odd years now, and it does all kinds of things. I understand he even has a functional configuration for salad mode, which when you use salad mode, the editor is even capable of ordering you food. Yes, you can load salad mode in Emacs, and if you're in the delivery area for the place that does it, you can get a salad.
The point is raised is why the heck do you load up an operating system to edit a file?
No comment. Right. So I'm going to make a change to this file real quick. So let's say that, I decided that perhaps welcome to M Shell, because my name is Michael, if you remember, perhaps it is a bit too self-serving to call my shell M Shell. So I'm going to highlight, I'm just going to say, welcome to the shell. That's all I'm going to say. And I can go ahead and save the file and write out, come back over and run make, and go ahead and rebuild my shell file. This is a very trivial example of using a text editor in the shell, but it does demonstrate that we don't have to jump out of the shell to do things with files. Now, why would we care about that? Because here on my laptop, I clearly have a graphical interface. I have various other programs I could have loaded to do that. Why would I do that in the shell? And this is where we have the real power of the system, which is that now I'm not on my laptop. Now I am on CS Linux 1. This is a host that the department provides for undergraduate students to do work in a Linux environment. If you're a graduate student, you would be using CS Grads 1. So yes, this is one of those servers. But because I have familiarized myself with the shell, I can do everything I could do on my laptop on CS1 now. And for certain things, CS1 is a very powerful computer. And so I may elect to do projects on CS1 where I don't have to wait, as opposed to my laptop, where it may take additional time to run. I think I still have a project over here. Yeah, project. So this is the same project in a slightly earlier phase over here. And I can open it right back up in the same editor. And I can scroll around, I can make all my same edits. Wow, this is before I put the comments in. Yes, because you never need comments, regardless of what you're told. Don't need comments. So yeah, but this is all happening on a remote system. I'm not doing this on my laptop. But because I'm familiar with the shell and I'm able to work with that, I can quickly switch over. For the sake of my associate over here not killing me after this meeting, I will mention that there is another editor that you can use. And I have been somewhat careful in the way I've talked about my editor, because within the open source community there is a bit of a holy war that has gone since the dawn of time over Emacs versus Vim. They are two insanely powerful editors. Anything you can do in one, you can do in the other. It eventually boils down to what is your personal preference, what is your style of work. Vim focuses on never take your hands off the home row. Emacs focuses on do literally everything. Sometimes in questionably efficient methods. So I'm going to load up that same file now in Vi, because I know that exists. Actually, yes. Then I'm going to hand over to Matthew, who's going to make the same edit I made in Emacs on this copy, and then talk just a bit about Vim and why you might want to use it.
Okay. Can you, what edit did you do?
I changed welcome to M Shell to just be welcome to shell.
Okay. So, Vim is a text editor. You have no salad mode in Vim. Vim focuses just on being a text editor. Generally, people will say Vim is a better text editor, Emacs is a better program. That's a huge part of the debate that's currently going in on our IRC channel. So, Vim is focused on using keys. There are different modes. So right now I am in normal mode. And if I am to type H, or I can't type H here, sorry, J, I'm going to go down the line. You can see my cursor is moving around and I'm pushing H, J, K, and L. Where's
Inside the main page.
Okay. I'm going to do a search. I type slash, and I can type M shell.
Lowercase m-s.
Okay. And so I'm just using normal characters. I'm going to type C, I, quotation mark. It's going to change everything in the quotation mark and put me into insert mode. where I can start typing hello, whatever, here. I type escape and I'm back in normal mode, and now I can navigate around, change things extremely quickly, not using chords, control C, control whatever, wherever you have, however many fingers you have for your chords. Instead, I'm just using normal keys.
Louder.
So there are a lot of things you can do in them. I am just scratching the surface of it, so I could not tell you everything. But it's important to know that it is a text editor. It's heavily focused on things you can do quickly in normal mode or visual mode where you can select things. It's very fast if you get to the limit.
Both Vim and Emacs are available on the CS cluster. Your default editor, though, if memory serves, is set to Pico, which is yet another editor. And when I asked about this, I was told that the CS Technical Support Division wanted no part in Holy War. So if you would like to use either of these fine editors, you can set them up yourself.
Pico is fine, but it's not going to be efficient and fast like Vim, Vi, or Emacs will be.
It also doesn't have pretty colors.
It does not.
Colors.
Okay.
Oh, come on. If you're looking at a 20,000 line C file, colors are nice.
Why are you looking at
It has the capability, it's not always
C
named.
files got to be
Okay,
large.
I can see that.
I would hope not.
I can see that. All right.
We'll talk about sudo and you.
Okay. So I'm going to jump back over to Earth for a bit, which is my laptop, because the next point in our talk is what if you need to be somebody that isn't you? I'm actually going to get my... No. Got rid of my nice big window. There we go. What if you need to be somebody that isn't you? Like, I am M. Aldridge on this system. What if I need to be somebody that isn't M. Aldridge? Can anybody come up with a reason for why I wouldn't want to be me? Like, why would I want to log in as somebody else?
Possible deniability.
Can anybody come up with a legitimate reason that is okay for us to talk about for why I wouldn't want to log in as me? I'm eyeing the people in the back here that I know this answer.
Edit your system as an administrator?
Yes. Yes. I might want to become an administrative user for a while, but I don't want to stay logged in as my administrative user because that would be dangerous. Then files might get inadvertently edited and then my system would stop working. The program that is provided to do this is sudo. Super user do. This program was originally written years and years ago as a way for the root administrator password to be safely stored inside of a program such that trusted administrators could work with the power of root without actually having to be trusted with the password. Sudo has since morphed into a much more powerful program which can draw upon sources from the network, it can draw from databases to figure out who's allowed to use it, all kinds of things like that. The task I'm going to do is going to be to update my system, because only the administrator is allowed to run the system updater. Don't want random users making sure I've got new Firefox. No. Only the root user may do that. So it will ask for a password, and it's asking actually for mine. So if I type it in, it's run that program not as me.
Yes.
Now, I can ask sudo for an interactive shell, and then I can say, who am I? And when it completes, I am root. Yeah. So sudo will allow me to become other users on my system, most commonly the root user. That is a sudo. If you have used another system, other families of systems, it is the counterpart to the program called su, which actually allows you to switch user to someone else. Su is much more manual because you have to remember to switch back to you at the end. Sudo just does that for you. Any question? Alright, so I'm gonna drop root authority. For fun on my system, if you remember we spoke about aliases, I have an alias for sudo on my system, just for the fun of it. I can do sudo xbps install, or I can do such xbps install. And the Doge needs all of my auths. This is an alias, it's literally just calling sudo and I've changed the prompt. This is one of the fun things you can do with the system and change things around. Question in the back.
Yeah, so if you have like a pipeline like we were talking about earlier and you use sudo, will it only do like the first thing with sudo and then the other things, how do you get them to also be sudo without typing it in multiple times?
Sudo will only grant authority to the first command after it which is called. So if you need your entire pipeline to run as root, it's probably easier to get an interactive shell and run your pipeline within that. If you only need part of the pipeline to run as root, then you can preface each command you need as root with sudo, and then sudo will cache your authority for a few moments. So you'll only be asked for the password the first time it's called.
Okay, and then like more of an extending on that, if you want to write to a file like with the
Yes.
sync, but it's a protected file, or maybe you want to append to a protected file, how do you use sudo to do that?
You can either operate in a root shell, wherein your entire pipeline is running as root. And that is generally the use case I have found. Or you can use a utility called T, which takes the input in from the stream, in from the pipeline, and then writes it to a file you specify. And because it's an actual program, you can preface it with sudo. And then T will allow you to work with those privileged files.
Just on the same lines, can you do alias for your all the pipeline and then use that alias to do the serial thing?
Yes and no. Sudo starts to get into interesting issues wherein parts of the pipeline may be running as different users and you're passing data back and forth and assuming that credentials are cached and things like that. And depending on the shell, the unpacking of the alias may happen before sudo even starts. So if the unpacking of the alias happens before sudo is run, only the first thing in the pipeline will be run as root. In other shells, sudo will run first, then the alias will be unpacked, and then everything that was in it will run as root. Good question. I hadn't thought of that one. All right. Yes. All right, so that brings us more or less to the end of where we plan to be today. We have some cool tools that you can run in the shell that we will stick around and talk about for a bit. If you want to learn more about the command line in general, if you literally Google the art of the command line, you will get to this GitHub repository. And this is where we pulled a lot of material for today from. It literally includes the basics, knowing what various commands are, everyday use, things like that. Right, sorry. You could have said that out loud. There we go. Sorry about that. Let me, now with this actually on the right monitor. Yeah, this GitHub repository has, in many different languages, a lot of the content we've talked about today, as well as a lot more than what we were able to get into in a limited amount of time. As well as some things that are OS X only. So for people who have Macs, that is a particularly useful category because it explain some of the programs that only exist on Macs. Are there any questions? Yes?
I came in a little bit behind. What was the colored highlighted shell that was being demonstrated?
That was a ZSH, and that's actually a highly customized ZSH. The colors and the angles and everything is part of a font called Powerline. If you Google, you'll find guides on how to set that up. It involves adding some extra fonts and then changing the prompt variables. But it's personally, I do not like that many colors in my prompt. Matthew here has been working with Powerline for quite a few years, and it.
That's the setup for ZSH?
ZSH, yes. He was using Powerline and ZSH, but you can install Powerline into just about any shell you want. It's a set of custom fonts, and then by customizing the prompt itself, you include this additional font which has the angles in it, and then you can include the color codes for each segment.
I want to make sure I heard the name of the actual shell correctly. It was ZSH, like beginning with Z?
Yes.
Zulu?
Yes.
Thank you.
That is the shell.
Shall we demonstrate the TMOC cow?
I do not have the mask file for the TMOC cow. No. If you see in this image here, there is a cow doing what's that? Yeah. Cowsay. The cow is just saying some text. A member of the LUG made an alternate mask file for this program, which is TMOC. So we will get in touch with that individual, see if we can get that mask file onto the website in the event that you want to have TMOC saying things in your shell. Alrighty, thank you very much for your time, everyone. If you have any questions, we'll be hanging around here for a few minutes to answer any questions you want. The LUG is, in addition to being a technical organization, we are also a social organization. So we, the officers and some of the longtime members of the LUG will be going out to get food after this. We generally go to the food court at the mall that is just north of here. If you guys would like to join us for that excursion and either can provide transportation or would like to seek transportation with our group, please join us up here at the front of the room and we'll get that trip figured out. Thank you very much.
One question real quick. So I'm a computer science student.
Okay.
I was wondering if I still